To visualize the correlation of time series, we first make a plot with all the data. In this case, we use the plot function and a scatter plot to associate solar generation with wind on the x-axis. We can put photovoltaic solar. And on the y-axis, we put wind. After executing, we encounter the first problem because many points appear due to hourly generation. Therefore, it would be ideal to resample the data, for example, weekly every 7 days. And tell it that I want the hourly average, which is more representative when relating two time series. We create a new variable. We name it weekly, execute, replace the variable in the plot, and here we observe the points clearly, how both time series relate. When plotting directly with the data frame, this type of object does so using the Matplotlib library. If I wanted to make an interactive graph to see on which day each point occurs, I could use the visualizations from the Plotly library. If I hover the mouse over a point, I can see information about that generation. Therefore, we import the Plotly Express library as peaks. Next, we use the scatter function, which asks for the data frame. In our case, it's the weekly one, which if we execute now, displays each value on its own. And that's because on the x-axis, we must tell it that we want one of the generations we have in the columns. Therefore, we will put solar on the x-axis and wind on the y-axis. Execute, and now we see here the relationship between both series clearly. If I hover the mouse over a point, the information of both variables appears. But I could also tell it here in hover data, for example, that I want to give it the temporal information that is in the index. Therefore, if I now execute and hover the mouse over a point, it tells me the moment it occurred. For example, in January 2023, here we have in December, while here in these months we have in summer, where solar generation is greater and wind lesser on the y-axis. To make the graph more compact, we will use some of the visualization properties. For example, I want the width to be 800 and the height to be 600. We'll make it a bit smaller, 600 by 400. Now, if we ask for one of the parameters we have in the function, we'll see one called trend line. If we look it up in the help, we can see the options we can use: OLs, log, rolling. In our case, we will use OLs. Therefore, trend line, OLs, execute. And here we have the line which, if we hover the mouse, tells us that the wind will be calculated as minus 0.81 by the photovoltaic solar plus 10,000. What does this mean? That for every megawatt of photovoltaic solar on average that we increase, wind will decrease by 0.8. That is, it will generate 0.8 megawatts less per hour. Although this regression is not very reliable because it has an R-squared of 23%. A clarifying note I would like to mention is that we are still not doing time series models. This is simply a correlation between two time series. The analysis of time series will be left for a future chapter. First, we have to learn how to work with time series and manipulate them, because most of the time we do not work with the data as given. In this case, we have worked with hourly data, not with weekly data. And there are many differences in whether you do the sum, the average, or also the specific time series you are working with. So if you are thinking of diving deep into time series, relax a bit, because we are going to learn the basics first, so that later, when we get to time series, we know where we stand. And above all, what kind of pre-processing we could apply so that time series offer us greater value. And to wrap up this tutorial, in addition to having made a scatter plot with the Plotly library, I would like to show you how to make an area chart. Therefore, using the weekly data, we go to the Plotly library and look for the area function. It also asks us for a data frame, X and Y. In the data frame, we can directly give it df renewable weekly. Execute, and here it automatically does not need to specify the X and Y because it takes from the data frame the temporal index on the X and each of the columns representing an area. However, here we have a problem because we are not representing the total weekly generation, which in an area chart is what would correspond. Therefore, when resampling, we would have to tell it that I want it every 7 days, and that instead of doing the average, I want the sum. Save the variable, we name it weekly total. And here we pass it execute, and now we have a more realistic representation. Because it is true that between wind and photovoltaic solar over the course of a week, they even managed to generate about 2,000 megawatt hours. In the next tutorial, I will explain how to make pivot tables. And this time, we have to make a small adjustment. Changing the generation columns so that they are by rows. I'll explain the whole procedure and why in the next tutorial.